Hello, today we'll carry out our discussion with random process. We shall carry out the discussion on statistical mean, variance, standard deviation, random process, stationary and ergodic processes, correlation coefficient, autocorrelation function, and the binary symmetric channel. Statistical mean is an important parameter which is required for various statistical calculation for the communication system. The statistical mean can be easily found out by the algebraic sum of the random variable and its associated probability. An example is shown with the table where the random variables are numerically assigned 1, 2, 3, 4, etc. The probability P is given in the second row, and the product X and P are shown in the third row. Now, if we take the algebraic sum of the X and P, that is the product of XP, we can find out the statistical mean. So expected value of the statistical mean as derived here, it is 4.5. Now, random variable is a numerical number which is found from a function associated for each of the outcome of a random experiment. So here the statistical mean is a weighted mean. The values with higher probability have higher contribution to the mean. Another important statistical parameter is the variance. The variance can be found out by this mathematical equation. Normally, variance is associated to the derivation of power of a random signal. We will see in later calculations. Now here, to derive the variance, we need only the random variable and the corresponding probability. So if the random variable numbers are known corresponding to each of the outcome of a random experiment, that is here 1, 2, 3, 4, 5, and 6, corresponding probabilities are given in the second row. Therefore, x square p can be easily found out. And if we find the algebraic sum of the x square p, then it is one of the item required for derivation of the variance of x. Similarly, the mu square can be found if we have the numerical value of the statistical mean as we derived in the last slide. So therefore, if we have the two values, we can find out the subtract, that means the difference, and corresponding variance here derived as 3.25. So numerical value of the variance is derived as 3.25. Another important parameter is standard deviation. Normally, in case of electrical communication, the random signal magnitudes are represented by the standard deviation. Standard deviation can be found out by the square root of the variance. That means once the power of a signal is known for a random signal, if we take the square root, we can get the magnitude of the random signal. So here the mathematical calculations are showing that standard deviation is the square root of the variance, and numerically the value has been derived as 1.803 in relation to the previous slide example. Here an example is given where if you plan to open a new franchisee of a reputed fried chicken center and found the statistics of similar restaurants. Here two columns are given, that is percentage of cases where of survey you have done and the yearly earning. So 20% cases you have seen $50,000 loss, 30% cases no profit no loss, that is $0. 40% cases in which $50,000 is the profit, and 10% cases in which $150,000 profit. So very high profit percentage is less, moderate profit is 40%, and 20% and 30% for the losses and no loss. So in such a case, if we want to find out what is our expected earning yearly, as well as what is the deviation, then we have to carry out the calculation for the mean and the standard deviation. So here the calculations are shown with reference to the previous table, where the probability are represented by the fractions as given the percentage in the last table, that is 0.2, 0.3, 0.4, all these things. So if you find out the summation of this probability equal to 1, that means you have considered all the cases. But if it is found that the summation of the probability is not reaching 1, that means some of the cases you have skipped need to be included for this calculation. Now here, for all the losses as well as no loss, as well as profits, all the cases are shown, and corresponding products xp, x square p, you have found, its summation also found. So therefore, it is easy to derive the statistical mean as well as variance, as we have discussed in the last slide. So therefore, it shows that the statistical mean is $25,000 for the large deviation of $56,000. So it is not a favorable calculation with reference to the profit of the business. So someone willing to enter into the business needs the mean expectation of the earning should be high with less amount of deviation. That means here the sigma is 56,000 with reference to the mean $25,000. So your expected outcome or expected earning is $25,000 with reference to a large deviation of $56,000. So it should be reduced, and 25,000 has to be increased. So therefore, we can carry out the same example with other numerical value, such as in case of $50,000 profit, if we consider the probability little bit higher compared to 0.4, in the next example, we will consider it is 0.7. So as shown, it is 0.7. That means 70% cases are occurring for $50,000. Therefore, we are getting again, summation of the probability should be equal to 1. It should not be large enough. As we have increased the probability to 0.7, so other probabilities has to be reduced so that the summation of the probability should be equal to 1. So in this case, what we find is that the mean derived is $45,000 and the standard deviation is $47,000. So therefore, it is quite obvious that the statistical mean is increased compared to the earlier cases of $25,000, which is a very good result or very good case study in favor of the profit of the business. So it will attract the person to enter into the business, as well as the deviation of the profit. That means variation of the profit has been reduced from 56,000 to 47,000. Therefore, this result is quite attractive compared to the earlier result. Random process is a major parameter which is required for the statistical communication. A random process can be found as an outcome of an experiment whose output is unpredicted, such as a noise generator. In the laboratory, we have noise generator. In the noise signal generator, we are turning on the device and we are finding the output voltage which are fluctuating with reference to time. So therefore, and that value are unpredicted. So therefore, such a process is known as the random process. Similarly, here an example is given for the stock market. What will be the stock price for the next 1 month has been given in terms of money, that is the stock price as magnitude, and it is fluctuating. Initially, it has lower magnitude, then it has been fall to a very low value, thereafter it has been risen, again fall, again there is a peak value it has reached, again there is a fall, again peak value. So in this way, totally uncertain domain in which the stock price is hovering, and it is giving a forecast for the next 1 month. So suppose someone is willing to enter into a stock market, he needs such a graphical characteristics for a particular business where he can invest. Random process has been further elaborated with sample points. That means for a particular random process, which may be a stock market, which may be a random experiment, in which the magnitudes are fluctuating. That is, in the whole discussion, it has been clear that whatever is the time period for which we are going to study, there is a fluctuation of the magnitude with respect to time occur in every cases, and such a random process is also termed as stochastic process. Therefore, a random process is a collection of random variables, usually indexed by time. That means random process, if sampled at a specific instant, we are getting the magnitudes of the random variable. So such a result of the random variable may be useful to derive the statistical mean or statistical variance standard deviation for a random process. Normally, such a random process may be continuous or discrete in time. Continuous random process means when the time span for which the process has been observed has infinite set of timing instant, and if the number of time instant is finite and discrete, then it is known as discrete time random process. An example given here: suppose you have $1,000 to put in an account with interest rate capital R compounded annually. That is, if xn is the value of the account at year n, then xn equal to 1000 into 1 plus r to the power n. So 1 plus r is a random variable. If the bank rate of interest is 4% to 5%, you have to find all the possible sample functions for the random process xn, find the expected value of your account at the year 3, that is after the end of third year. What is the expected value of your bank account? You have to calculate. So these are the things you have to calculate. So if you process towards the solution, then you can find out the equation of x3 can be given as 1000 into 1 plus r to the power 3. So 1 plus r is again a random variable which is defined by y. So it has been assumed y is equal to 1 plus r. Therefore, probability density function of y can be written as it is 100 for 1.04 less or equal to y less or equal to 1.05, and it is 0 for otherwise cases. To obtain expectation of x3, that means the expected value of your bank account at the end of 3, it is nothing but 1000 into expectation of y cube, and the numerical value has been derived as 1141.2. Some other examples are also carried out. If we go through these examples, you will understand that statistical parameters are very much beneficial for such a forecast. Now, here is an important term: stationary process and ergodic process. Normally, random process or stochastic process may be stationary if the joint probability is not varying with respect to time. So here, the definition states that if the joint probability is not varying by changing the time for a random process or shifting the time for the random process, therefore the system is called stationary. And ergodic process is another stochastic process or random process for which a long random sample, if observed, we are getting the full statistical characteristics from the same sample process. So therefore, ergodic process is nothing but a sample function that we are getting by observing the stochastic process, which are giving the full statistical characteristics. Now, regarding the stationary or and ergodic process, there are some definitions we should remember, such as the mean function. Mean function is nothing but the expectation function, which may or may not be dependent on t. Also, second order process, a stochastic process is said to be second order process if the second order moment is finite. That means it is less than infinity. The covariance function C of st, where s and t are two different timing instant, can be derived from the difference of the product, from the difference of the joint expectation of xs and xt and the product of the expectations at xs and xt. Also, there are some other important definitions, such as the autocorrelation function given, which are very much important for the derivation of several other statistical characteristics. Now, here are the important definitions of the ergodic property given. That means ergodicity, which we already have discussed, strictly sense stationary. So this strictly sense stationary is important. It is almost the same definition as we discussed with respect to the stationary process. That means the stochastic process should have the joint probability which is not changing with reference to the time. There is another stationary process which is known as the white sense stationary process, in which the expectation of the random process is required to be independent with respect to time. The square value of the expectation of the square value of the random process should be finite. The covariance function of the should be dependent on the time difference t and s. So in such a case, the stochastic process is said to be white sense stationary process. The correlation coefficient is also another important property. It may be derived for two variables in a data set equal to their covariance divided by the product of their individual standard deviations. So this correlation can be found for the same random process in which the two random variables are observed at two different instants of time, and therefore the correlation can be found for the two sample points. Here the covariance of xy is given as the mathematical expression summation of expectation, that is a product of the expectation of x minus mu and y minus v divided by n minus 1, where n is the number of time items in the data set. The autocorrelation function is also another important property of statistical characterization of communication system, where expectation, it's a joint expectation of the two random variable xt1 and xt2 has been uh, found with another mathematical expression. This autocorrelation function tells us the similarity between the two random variables which are observed from the same random process xt. Binary symmetric channel is one of the important uh, characterization of the communication system, in which we are considering there are two stations. One station is transmitting 0, another station is transmitting 1. So here 0 transmission may be received as 0, 1 transmission may be received as 1, but there are chances of crossover probability, that means error probability, that means 1 is transmitted received as 0, but 0 transmitted received as 1. Therefore, a binary symmetric channel is a common communication channel model which is used for coding theory and information theory. So it is a theoretical characteristics, and it gives us speculations for various real time communication problems. In this model, a transmitter wishes to send a bit 0 or 1, and the receiver receives a bit. It is assumed that the bit is usually transmitted correctly, but that it will be flipped with a small probability. This channel is used frequently in information theory because it is one of the simplest channel to analyze. A binary symmetric channel with crossover probability p denoted by is a channel with binary input and binary output and probability of error p. That is, if x is the transmitted random variable and y is the received random variable, then the channel is characterized by the conditional probabilities, and such conditional probabilities are four types. The first one is probability of y equal to 0, so that x equal to 0 transmitted. So it is a correct reception, and that is equal to 1 minus p, because p is the crossover probability, that is error probability. So for the error probability, there are two cases: probability of y equal to 0 provided x equal to 1, and provided probability of y equal to 1, x equal to 0. So such a crossover probability are of similar probability, that is denoted by p here. Another one is correct probability, that is probability of y equal to 1 provided x equal to 1 transmitted. So it is also 1 minus p. So it is assumed that 0 less than p less or equal to half. If p is greater than half, then the receiver can swap the output, that means interpret 1 when it is seeing 0, and vice versa, and obtain an equivalent channel with crossover probability 1 minus p equal to half. This channel is often used by theorists because it is one of the simplest noisy channel to analyze. Many problems in communication theory can be reduced to a binary symmetric channel. So therefore, such a binary symmetric channel is a theoretical model for the calculation of several practical situations. Thank you.